Okay, so it seems that it's not possible to move forward in this chapter without having a review. And we need to review basically at least the concepts that we had in basically statistics class 10. So this is basically what I want to review here is this basically statistics basically class 10, the same basically family of books, meaning that you can go over here and go to class 10 and mathematics, and then mathematics and go. And if you go to chapter 14 of this book, you can of course download this book over here, and you see you have basically 35 pages of statistics here. So you have basically the mean of group data, and then you have the there are some exercises here. Of course, I'm not going to go through the exercises for this review, probably some of them. And then you have the median of group data. And then you have some other things as well. There are some exercises and so on and so forth. So we will go through this chapter, so you can, in order for you to be able to follow along, you can also download this book if you need to. So it's basically the statistics class 10 chapter 14. Okay, so now there is basically a concept that first we need to understand, and that is basically the concept of group data and ungrouped data. So basically there is the concept of group data, there is the concept of group data and ungrouped data. And what that means is that basically if you have a set of observations, let me show you using an example. Okay, so again I have to go a little bit more back to get to group data and ungrouped data. Okay, so grouping data is basically a simple process, basically that makes basically logical sense, what that is that basically most of the time, of course all the time, when you collect your data, if you don't have any system for the collection of your data is going to be unorganized, meaning that anything that is unorganized, you cannot use it in any systematic way. So now, in order to be able to use your data in a systematic way, or use it in basically applies any sort of formulas of a statistic on it or anything like that, you need to group it, meaning that you need to organize your data in the ways recognized by statistics, so that rest of the body of statistics can work on your data. So basically there is something called the unorganized form of the data. The unorganized form of the data is called raw data. Okay, it's called raw data. So basically the raw data we need to organize it systematically. So for example, let's say that you have a group of students and you ask them for their favorite subjects, and the result is shown as below. For example, you have a group of students and one of them tells you, for example, art, another one tells you, for example, mathematics, another one tells you, for example, science, another one tells you, for example, English, another one tells you again mathematics, another one tells you, for example, art, another one tells you English, another one tells you again mathematics, another one tells you, for example, again English, and another one tells you, for example, again art, another one tells you science, for example, again, another one tells you, for example, again art, again science, again science, and mathematics, for example, again art, English art, for example, art, English art, science, mathematics, science, mathematics, science and art. Science and art. Okay, so that's the list that you get from all of these students, and as you can see, you have had basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22 students, assuming that each student had only one favorite subject. And then, for example, suppose that you want to answer the question, which is the most liked subject, and the one that is the least liked subject. So the most liked subject, the most liked subject, and what is the least liked subject? What are these subjects? So in order to find out what is the most liked subjects, you need to, of course, start counting. For example, art is happening 1, 2, 3, 4, for example, 5, 6, 7 times, and then so art is occurring 7 times. Mathematics is 2, 3, for example, 4, 5 times. Maths is happening 5 times. For example, science is 1, 2, for example, 3, 4, and 5 times. Science is occurring 5 times, and so on and so forth. And so you need to then list each and every one of these subjects, and then depending on these numbers and these number of occurrences, then you can say that, for example, this was the most liked subject and this was the least liked subject. That's the only way to do it. And then of course this would be a tedious job to go through this list and count these one by one. So one thing that you can do, you can basically organize the data that you have. So what you can do is that you can basically organize your data in this way, meaning that you can see that you have art, you have mathematics. Let me color code this. You have mathematics, you have for example science, you have English, you have again mathematics, art, English, mathematics, English, art. You have science we have already done, art we have already done, science we have already done, science, mathematics, art, English, art, science, mathematics, science and art. So in total you have 4 different subjects. You have art, you have mathematics, you have science, and you have English. So that's the 4 different subjects that you have. So then you can, based on the data that you have, you can form a table here. And then usually you can use tally marks. These are called tally marks. It is like the marks that sorry, we shouldn't have done this here. So these tally marks are supposed to be, so let me add another row here, and here I can write basically subject, and here I can write tally marks. And here I can write, for example, the number of students. Okay. Now, for example, you can count art here. So you have 1, 2, 3, 4, 5, 6, and 7. So you have seven marks for art. So you have basically 1, 2, 3, 4, 5, and 1, 2. That's 7 marks for art. And that means that the number of students that picked art was 7. Now let's count, for example, mathematics. Mathematics is 1, 2, 3, 4, and 5 here. So you have 1, 2, 3, 4, and 5, and the number of students would be 5. Now let's count, for example, science. Science is 1, 2, 3, 4, 5, and 6 here. So you have 1, 2, 3, 4, 5, and 6 here. And now let's count English. English is 1, 2, 3, 1, 2, 3, 4. So 4 marks here. 1, 2, 3, and 4. You have 4 marks here. So now, based on these numbers, you can very easily decide and answer those questions. So you can say that, for example, you can say that now the least liked subject was for example English, and the most liked subject was art, because the number here, the number of students who liked art was 7, and the number of students who liked English was 4, and then 5 and 6 come between these two numbers. So now this number over here, these numbers, basically all of these numbers, are called the frequency of this subject. These are called the frequencies of each respective subject. So these are called the frequencies of each respective subject. So the frequency basically gives the number of times that the particular entry happens. Okay? Now, so now this table, what you can call this table as frequency distribution table. You can call this table as the frequency distribution table. This is the name of this table because you have all of your entries here and then the frequency related to those entries. So this is called the frequency distribution table. So that's basically why in the first place you have to organize your data. Okay? Now let's get to basically grouping data. Grouping data is one of the things that is also very popular in mathematics. In statistics. So let's talk about grouping data. Grouping data. Okay, so now about basically grouping data. So the data regarding, for example, choice of subject shows the occurrence of each of the entries several times. So basically when we were talking about all of these basically subjects, we saw that these subjects were being repeated several times, and then based on that we created the frequency distribution table related to this data. Now this kind of data, usually you can show this kind of data using, for example, some visual. You can have some sort of visual representation of the data. For example, as a very quick example, I can show you, for example, the way that you can show this data on something called a bar graph, for example. Of course, there are many different types of bar graphs. There is the histogram. There is all of these similar things, but in essence, they are basically the same thing, meaning that you have all of your subjects. For example, over here you have art, you have mathematics, you have, for example, science, you have English, and then, for example, this goes from 1, 2, 3, 4, 5, 6, and 7. So this is 7, and then you have, for example, art over here. Art takes, for example, gets a 7. So that is basically art, and that is basically called a bar graph. Then mathematics gets a 5, for example. That would be, for example, something like this. And science gets a 6, for example. So that would be, for example, something like this. Or for example, English gets a 4. So that would be, for example, something like this. And so that is the visual representation of your data, and that way you understand basically, for example, that art was chosen by 7 students. Mathematics was chosen by, for example, 5 students. This is 7, this is 6, and this is 4, for example. So that's the visual representation of your data. There is also the pictograph. There is all kinds of different types of visual representation of data. But then when you're dealing with large amounts of data, then this kind of thing does not work anymore. You have to get into algebra. And so meaning that when you have to deal with large data, suppose that, for example, the marks obtained in mathematics by 60 students. For example, the marks obtained by, and that is of course related to grouping data. We want to talk about grouping data. Grouping data. Okay, so now suppose that you have the marks obtained by 60 students. You have the marks. You have the marks obtained by 60 students. For example, in mathematics, out of 50. All the marks are out of 50. So you get basically, you have 60 students, so you get 60 separate and not necessarily distinct, but 60 marks you will get. Meaning that you will get 21, you will get 10, you will get 30, you have 22, you have 33, you have, for example, 5, you have 37, you have 12, you have 25, you have 42, you have 15, you have 39, you have basically 26, 32, 26, 32, 18, 27, 28, 19. Okay, so you have 28, you have 19, you have 29, for example. You have 35, 31, 35, 31, 24, 36. But I'm taking the time to talk about these topics because without these you will not be able to understand really anything in statistics. The statistics is just about a couple of simple situations, but those situations you have to understand through basically simple examples, and then based on that you can derive your own formulas. So 24, 36, 18, 20, 38, 18, 20, 38, 22, 44, 16, 24, 10, 27, 39, 28, 39, 28, 49, 29, 49, 29, 32, 23, 32, 23, 31, 21, 31, 21, 34, 22, 23, 36, 24, 36, 33, 47, 48, 50, 48, 50, 39, 27, 16, 36, 45, 47, 30, 22, and 17. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Maybe one of them is missing. I'm not really sure. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So that's 60 numbers. Now, if you make the frequency distribution table for these numbers, now the problem, basically the frequency distribution table we made a frequency distribution table, for example, for these subjects, and the number of subjects were only 4. So you got 4 subjects here, and then the tally marks for them and the frequency for them. But now, if I want to make the same table for this data down here, it would be practically impossible. And over here we are basically dealing with numbers with possibly all the numbers between 1 to 60, right? I'm sorry, 1 to 50, not more than that. So that would be at most 50, basically 50 distinct numbers or so, right? So even for 50 numbers, it's not possible to do the same thing, meaning that I cannot write, for example, I cannot create a table over here and write over here, for example, okay, so this is 21, and then I have 10, and then I have 30, and then I have, for example, 22, and so on and so forth. I would get 50 rows over here, which is not something that you could do. It's not practical. It's not even possible, especially when now 50 numbers you might be able to do it, which would of course be pointless. But the more important thing is that when the number of numbers gets to, for example, 50 numbers or so, then it's absolutely impossible to do it. So we need to find some other way to do this. So for the sake of convenience, what we can do is that we can make groups of observations. So what you can do is that you can go for example, you can make this kind of table for your observations, and for example say that, okay, so these are, I call these, for example, groups of, for example, I know that my numbers go from 0, for example, I take it from 0 to 50, for example, at most. So I can go for 0 to 10, for example, and then 10 to 20, and then I could go from 20 to 30, and then I can go from 30 to 40, 30 to 40, and then 40 to 50, right? I can do that. Of course, as you can see, now what I logically need to do here is that I call these, for example, groups. I call these groups, and for example, I will have the same tally marks here. I will have the same tally marks here, and then again the frequency, or the number of students in each group. And so then what happens is that basically I can start counting. So for example, 21 would be over here, so I can add a mark over here. 10 is over here. So for example, then 30 would be, now for example, for 30 you need to add it to this group over here. Now this is a matter of agreement and convention. And for example, then 22 would be over here. 33 would be over here. And so on and so forth. And if you complete this table, you would get something like this. So you would get basically 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. You would get 4 to 21. So 21, for example, 5 times 4 is equal to 20, 21. This is 10, this is 2. And then you would get 19 here. So 4. This is 15 plus 4 is 19. And then you have 1 over here. So if you add all of these numbers together, your total would be 12, 13. 13 plus 21 is equal to 44. 44 plus 20 is equal to 64. Oh, that is something wrong. 2, 10, 21, 19. Oh, we have a 7 as well here. So 0 to 10, 10 to 20. Oh, we have 60 here as well. Sorry. It's out of 60. Then the marks are out of 60. I didn't know that. Although there is no number above 50 here, I suppose. But, well, the marks are out of 60. And it seems that there is one number actually above 50. Okay, so we have basically 50 to 60 as well, and you get we need a 7 here, and then we need a 1 here, so that's a 7 and that's a 1. So then if I add all of these together, call this total, the total would be basically 3 plus 7 is equal to 10, 10 plus 10 is equal to 20, 40, 60, and that's a 60. So your total will be 60, and that's basically, by the way, also the number of students. So now this way, it's probably the only way that you can do this, and the only way that you can group that you can represent your data. But the problem is that now you will basically lose some information, meaning that, for example, normally if you were to take the mean to calculate the mean of all of this data, you would add them all together one by one, and then divide that sum by the number of those numbers. So you would do that. You would divide the sum of the numbers by the number of those numbers. but in this case, now I know that basically in this group, which is all the numbers that fall within the group 0 to 10, which is by the way also called the class interval. So that, yeah, I know that there have been 2 such numbers in this group, but I do not know what their values were. So if I were to add them together, I wouldn't know what to do, right? But if I had the numbers themselves without specifying a group for them, I could say that, for example, my numbers are x and y, and then the mean of those numbers or the average of those numbers would be simply x plus y divided by 2. But over here, now I need to, again, basically find some way in order to mean up those numbers, and we will get to those parts as well. So that's basically called, the frequency distribution table is going to be this. Now let me see what we have here. So if you make a frequency, so it says that if you make a frequency distribution table for each observation, then the table would be too long. So for convenience, we make groups for observations, say 0 to 10 and 10 to 20 and so on, and obtain a frequency distribution of the number of observations falling in each group. Thus, the frequency distribution table for data can be like this. And so the data basically represented in this manner is said to be grouped, and distribution obtained is called grouped distribution, grouped frequency distribution. So one thing that basically there is some terminology that you need to know, because they actually show up everywhere in the statistics, including in the chapter that we are currently doing, and that was basically why I had to go back and do this chapter. Do this review. So the data represented in this manner, when you define basically all of these groups here, the data represented in this manner is said to be grouped data, and the distribution obtained is called grouped frequency distribution. Grouped frequency distribution. So this table, for example, you can call it a grouped frequency distribution table. Now, using this table, there are things that, of course, you can do. For example, you can say that most of the students have scored, for example, between 20 and 40, for example, as you can see here, 21 and 19. So you can say that most of the students have scored between 20 and 40. Or you can say that basically, for example, you can say that 8 students, 7 plus 1, 8 students have scored higher than 40, for example. And, well, such things. But it's going to be an overall measure of how the students were doing, and you cannot talk about the individual basically observations, because the individual observations are simply not there. So that's the only problem there is, which is basically an unavoidable problem that you have to deal with in case you want to deal with large amounts of data and observations. Okay, so now basically we talked about these groups. So each of these groups is called each of these groups here is called a class interval. Each of these groups here is called a class interval. And briefly, you can call it also a class as well. Now you can of course see that, for example, 10 occurs in this class interval and also in this class interval, and also basically, for example, 20 occurs here and also here as well. 30 occurs here and also here as well. 40 occurs here and here as well, and so on and so forth. So but the problem is that you can, for example, when you have the observation 10, you have to basically have a way to decide whether 10 is going to belong to this class interval or to this class interval. And to basically to solve this problem, we adopt the convention that the common observation will belong to the higher class. The common observation belongs to the higher class, meaning that 10 belongs, if you have a 10, that 10 belongs to this higher class here, and then meaning that to the higher class, meaning that now this is the problem that I had as well. 10 belongs to the class interval 10 to 20. For example, 10 by higher class, they mean basically this class over here, and that means, for example, the class 10 to 20. So for example, if you had an observation 10, that 10 would belong to this class interval and not to this one. So that means that 10 doesn't belong here. All the observations from 0 to 9 go into this class. All the observations from 10 to 19 go into this class. All the observations from 20 to, for example, 29, 10 observations go into this class. Again, 10 observations 30 to 39 go into this class. 40 to 49 go into this class, and so on and so forth. So now in this class interval, for example, 10 to 20, in this class interval, for example, 10 to 20, 10 is called the lower limit, the lower class limit. This is called the lower class limit. And 20 is called the upper class limit. And in the same way, for example, 20 is called the lower class limit in this class interval, and 30 is called the upper class limit in the same class interval. And of course, you can see that the difference between the lower and upper class intervals in each case is 10. 10 minus 0 is 10, 20 minus 10 is 10, 30 minus 20 is 10, 40 minus 30 is 10. And basically they are equal, meaning that the length of each class is equal to the length of the next class and the next class, and so on and so forth. And the difference between the upper class limit and the lower class limit is not called the length, but the width or the size of the class limit. So for example, in this case, 20 minus 10 is equal to 10, and that is basically the difference between the upper and lower class limits, and that is basically, technically it's called the class size, or the class width, okay? Now, so that's everything that you need to know about for example, this kind of situation. Now, suppose that there is something else that we need to, that we can, well, as long as we are talking about this, so let's discuss these as well. So there is, so we had the marks obtained by students out of 60, which was basically something like this. So we had the class interval here. Let me write this properly. So we had the class intervals here. We had the class intervals and the frequency. Okay. And then the class intervals go from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. And the frequency of these were basically 2. Then we had 10, 21, 19. Then we had 7 and 1 and 2, 10. Oh, there is something that I forgot. So we had 2, 10, 21, 2, 10, 21, 19, 7 and 1. And the total of this would be 60. Because the number of students was actually 60. Now, to display this, this is the grouped frequency distribution of the marks obtained by 60 students in a mathematics test. So if you want to talk about this using the right terminology, you would call this the grouped frequency distribution. You would call this the grouped frequency distribution of the marks obtained by okay, so then you would call this the grouped frequency distribution of the marks obtained by 60 students, of the marks obtained by 60 students in a mathematics test, for example. In a mathematics test. Now, to display this graphically, what you need to do is that you you need to show this using something called a histogram. So a histogram is something like this, and basically you can go, you have, for example, let's say you have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22 here, for example, because this goes all the way up to 21. And so this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. Now what you need to do, so since your class intervals are continuous and starting from 0, you have to take some constant width from the very beginning of your, from the very edge of your coordinate system. And for example, that would be basically the class interval, for example, 0 to 10. And then 10 to 20 is 10, for example. So the same width, and you go all the way up to 10. And basically then that would be basically 10 to 20. Now 20 to 30, for example, is 21. So again, this, you pick the same width here and you go all the way up to 21, for example, here. So this is, let's say this is 21, this is 20 to 30, for example. Now 30 to 40 is, for example, 19. The same width, 19 here, for example, this is 30 to 40. 40 to 50 is 7. So 7 would be somewhere over here. This is 40 to 50. And 50 to 60 is 1, which is basically somewhere over here. Which is basically somewhere over here. Let's call it 1, for example. So this is 1. So this thing over here, and there is usually these points over here, or these dots over here. And there is, of course, all kinds of things that you can do with these kinds of graphs, meaning that, for example, the area under the graph represents a certain thing, but we don't really need to talk about those things anymore. Those kinds of things you learn when you basically when you learn how to basically do this for the first time in class 6, 7 or something like that. But when you get higher than that, then you don't really need to represent your data graphically, at least for the purposes of learning statistics in general, or at least for the purpose of understanding all the concepts in this chapter. You don't really need you don't really need to know how to draw a histogram exactly, so that there is no point in talking about them. So then basically this thing over here is technically called a histogram. This is called a histogram, and that is a way to represent basically group data graphically. Okay. So that is basically called a histogram. And there is other things like, for example, circle graph or pie chart or things like that, which is the kind of graph that you do in a circle, which is not that important right now. And it's very simple, and you just need to divide your circle into different segments. You just need to divide your circle into different segments, which is not that now, in order to show you, for example, one example here, So let's say that you want to find, for example, 320, 120, 160, 80, and 40. So, for example, let's say that the total sales of a shop has been something like this. So you have sold all of these items. So you have sold these items here, and these are the prices in rupees. Prices in rupees, and then you have the fraction of the whole. The fraction of the whole. And then you also need the central angle related to that fraction. I will tell you what I mean by all of this. So let's say that you have sold, for example, you're the shopkeeper. You've sold some ordinary bread. You have some ordinary bread. You have sold some biscuits. You have sold some cakes and pastries. You have sold some fruit bread. You have sold some other things. Now, the sale the sale, basically not the prices, but the sales in rupees. Price is different concept, of course. The sales in rupees were basically 320, over here 120, and then you had, for example, 160, and then you had 80, and then you had 40. If you add all of these together, you will get basically 440, 540, 600, and 720. 720 rupees, right? And moreover, what we have is basically, now you want to represent this data in the form of a pie chart, or one of those round charts like a pie. It's exactly the shape of a circle. So what you need to do is that basically in total you have basically sold 700. You have sold items of worth basically 720 rupees in total. And for example, this first one has been, for example, 320 divided by 720. Now 320 divided by 720 is equal to 16 by 36, and divide by 2, you will get 8, divide by 2, you'll get 18, divide by 2, 4, divide by 2, 9, that's 4 ninths. That is basically 4 ninths. Then you have 122, for example, 720. This would be 120, 720. That means that this is the fraction. If you want to express the sales of biscuits basically relative to the whole sales, that would be this fraction 120 divided by 720, which is basically 12 to 72, and then I suppose divide by 2 6, divide by 2 36, and then that's 1/6. And then, for example, this would be 160 divided by 720 as a fraction. 160 divided by 720, which is 16 divided by 72. So divide by 2, 8, divide by 2, 36, divide by 2, 4, divide by 2, 6, divide by 2, 2, divide by 2, 3, that's 2/3. Again, over here you have 80 by, for example, 720. Now 80 by 720 is the same thing as, well, 8 to basically 72, and then 4 to 36, and that is 1/9. That is 1/9. And then you have 40 to 720. 40 to 720, which is basically 4 to 72, 2 to 36, and 1/18. And that is 1/18. So that's 40 to 720, which is equal to 1/18. Now, so that is the basically as a fraction of the whole. This is 4/9, this is 1/6, this is 2/3, this is 1/9, and this is 1/18. Now suppose that you want to, of course, all of these are, I suppose, all of these are supposed to be equal to 1, I suppose, right? Because if you add 4/9 plus, all of them are actually supposed to be equal to 9, to 1. Because 4/9 plus 1/6 plus 2/3 plus 1/9 plus 1/18. So if I take 18, I will take the LCM as 18. So that's 8 plus 3 plus 12 plus 2 plus 1, which is equal to 11/23. Plus 12 is equal to 23, 26. It's not supposed to happen. 4/9, 1/6, 2/3. Oh, okay. There's a mistake that I made here. 160 to 720. 160 to 720. Is basically 16 to 72, 8 to 36, 4 to 18, 2 to 9, that's 2/9. That is 2/9, 1/6, 2/9. Okay. So now if I correct the mistake here, so I have 1/6 and 2/9 here. 2/9. So again, LCM has 18, 8, 3, 4, 2, 1. That will give me basically 11 plus 4 is equal to 11 plus 4 is equal to 15. 15 plus 3 is equal to 18. As you can see, that is 18/18, which is equal to 1, because these are all a fraction of the whole. Now, now you need to know, you need to calculate here what sort of central angle would represent, for example, this fraction of a whole, meaning that a full revolution around the circle, a full revolution which corresponds to basically one whole basically, that means that, for example, if the whole is 720 here, which is 720 divided by 720, which is the whole, which is equal to 1, that would correspond to 360 degrees. So now so that means that 1 corresponds to 360 degrees. Now if you have 4/9, and if I multiply it by 360 degrees, that would give me 160 degrees. So that gives me basically 4/9 times 360 degrees, which is equal to 160 degrees. Or 1/6 times 360 degrees is 60 degrees. Or 2/9 times 360 degrees is 480 degrees, for example. And 1/9 would be divided by 2, 40 degrees, for example. 1/18 divided by, well, 1/18, 360 degrees times 1/18 is equal to basically 2 times, that's a 21, that's around 20 degrees, right? 20 times 18 is equal to 36, 20 degrees. Okay. So now what you can do is that basically draw a circle like this, any circle would do, and just a normal circle, and then basically come over here and select the border, and okay. So now suppose that you have this circle, and for the sake of simplicity I draw these lines here so that I know what I'm doing, and then I can start from here. So for example, I can go for 160 degrees. This is 90, and this is 180. So a 20 degree angle would be, so this would be basically, this would be 45 degrees from here, and half of 45 degrees would be 22.5. So half of this angle would be approximately here, so this would be across approximately 20 degrees. If this is 20 degrees, then this is 160 degrees, right? So I can now get rid of these two lines and take this as 160 degrees, and the other one as, for example, so I can call this, for example, 160 degrees, which is the same thing as 4/9, and that is ordinary bread, right? Over here, there is a 20 degree over here, which I can call 20 degrees. And that is 1/18 as well, so I can specify that as well, and that I can call others. Of course, you can color code these as well, and then color these if you want to. And then we have a 60 degree angle and a 90 degree angle. So let's take this, for example, 80 degree angle. So let's say that, for example, the 60 degree angle is, let's say that basically this is a 30 degree angle. So this is the 60 degree angle, and call it, for example, 60 degrees, or or 1/6 and call it, for example, biscuits. And biscuits, and then an 80-degree angle. So this is a 30, so you need a 50-degree angle over here. So a 50-degree angle would be this is a 45-degree angle somewhere over here. Call this a 50-degree angle. So that's an 80-degree angle. Take this as an 80-degree angle and then call it an 80 degrees and 2/9, for example. And that is basically cakes and pastries. Cakes and pastries. And then you have a 40-degree angle, which you can call this a 40-degree angle, which is 1/9, and you can call this the fruit bread. You can call this the fruit bread. Okay. So that is basically, for example, called a pie chart. That is called a pie chart. Okay, so that's basically that. Now, I don't know why we came here. Yeah, we wanted to, this was, okay. So now I'm going to end this video. I think we need some more theory here, some more review. I will have to find a couple more things here, and then we will add them here and we will move on. So I will see you in the next video.